You're going to be watching the tutorial. It is how do I determine if a relation is a function. To go ahead and get started, what you're going to need, you're going to take this piece of paper. We're going to create our foldable, and this will be where you take all the notes. So the first thing I want to do is I want to kind of fold it hot dog style and leave a little bit of a crease at the bottom. And when I do that, I will have it looks like this. And then from here, I'm going to take this, all I'm going to do is I'm going to make a couple different folds. I'm going to fold it over in half, lengthwise, fold it over. And then I'm going to make one more fold of the same thing, just fold it over again. And now when I open that back up, I have the foldable that I'm going to need to be able to take the notes on determine if a relation is a function. Well, here what I can do is I'm going to go ahead and show you is make a cut on all the creases. If you have scissors, if not, you can do this when you get back to school tomorrow. And so one more time, and so now I have the foldable that I need to be able to look under each section. Now I'm going to move this out, and I have cheated and I've done the whole thing, and so now we can actually talk about the lesson. So the different things we're going to look at are and be able to determine if a relation is a function. 4 different elements. You're going to be looking at if I'm given a graph, given ordered pairs, given a table, or a diagram or mapping. So what I'm going to try to hold these over and focus on one at a time. First thing I want to look at, and this is something I think you've seen in the past, is being able to look at the vertical line test and be able to draw a vertical line, a straight up and down line on each thing and each relation to be able to tell if it's a function or not. So in this case, as I draw my vertical line and I'd go up and straight down, if I pass through more than one coordinate pair on each line on the line with just one line there, it's not going to be a function. So for example, this first one, if I was to draw my vertical lines over and over, I'm only going to hit one coordinate pair on that line each time I draw the line. But when I look at the second one, well, when I draw a line straight, a vertical line up and down, well, I'm going to hit one, say here, and on that same line I would hit a second one. If I do that, it's not going to be a function. It can only hit one line. I'm going to look at the last one down here. It's a line that goes straight across. Well, if I do my vertical line test again over and over, straight up and down, I'm only going to hit one coordinate pair on each of the lines. Now you're going to learn what kind of slope this is later, and we'll talk about that. But now if that line went straight up and down, that's not going to be a function, because if I went up and down and say this line was up and down, straight up and down, it would not be a function because I'm going to hit every coordinate pair along that line. It's definitely going to be more than one. So what I want you to make sure you do is go and make sure you pause the video, and I want you to write these notes. Talking about the vertical line test, if it passes through more than one line, one coordinate pair through the line, it's not a function, and that way you can have that. Now, as I'm going to move on to the ordered pairs, we're going to look at the difference of those. So yes, on the outside of the foldable, I do want you to write given ordered pairs, and then we're going to look at some. Here, as I look at these, and I do, again, I'm going to leave this up for you to be able to copy this, because I want you to be able to see what is a function, was not as a function, and actually have a definition to go with it. But if the x values of the ordered pairs are repeated, it's not going to be a function. You could either look at the x value, domain is another term, input is another term, and so I want to look at the difference here. I look and I see, okay, here my x and y, and x and y, x and y. Well, in this case, my x's or my domains never repeat. They're all different. I have 3, 2, and -3. They're all different. And for that same x, I have a y, 4, -6, -6. It doesn't matter if the y value repeats or not. It's the domain. If it repeats, it's not a function. For example, I'm going to look at the bottom one. I have 3 as a domain and then a 3 again. So this automatically, I know if that domain repeats, it is not a function. So let's look back up at the notes here. And like I said, I want you to be able to copy these notes. If there's an x value and a y value in each ordered pair, it is a function. The y value can repeat and it still be a function. All right, the next thing I want you to look at is given a table. Well, if I have a table, it's the same. You'll find the function rule, it stays pretty much the same. If the x values in the table are repeated, it's not a function. In other words, all this is really is just a different look to saying the same thing. You hear me say all the time, process never changes, only the look. Well, here we are again. X value, if they're different, in this case for your x's, you have -4, 0, 2, and 5. They never repeat. Again, the y, it doesn't matter if the y value repeats. It can repeat, every one of them be the exact same number, and it can still be a function. But now here, with the x value, I have 12, -4, 12, 16. I know because the 12s repeat, this is not going to be a function. So if I look at it, if I'd actually draw this coordinate pair out, and I would actually graph them, you're going to see that they're not going to be a function. So again, domain cannot repeat and it still be a function. Same thing as ordered pairs. And then as we move on, and I want to take a second, pause it, and actually copy this down as well. All right, and then the last one, if I'm given a diagram or a mapping, could be the term that you're given. If an input maps to more than one output, it is not a function, which means that is another way of saying if the x repeats, it's not a function. But if your input doesn't repeat, it can be a function. So we're looking at our examples. This one being a function, even though yes, they all go to this same thing. So the y's would repeat, but that doesn't matter. The y's don't have to be all different. So here, if I looked at like coordinate pairs, I'd have 4, -7, 3, -7, -2, -7, and then 10, 4. Again, yes, the y would be repeated over and over. That doesn't matter. What matters is I look at my domain, 4, 3, -2, and 10. They never repeat. So therefore, this one is going to be a function. But when I look at the other example, and I look at, say, okay, 3, 1, 3, 2, I know the x or the domain input is going to repeat. This cannot be a function. Then I look at 4, 3, and 4, 5. They're not, again, the x is going to repeat, or the input will repeat on it, and you cannot have that being a function.